Matthias Sax is a software engineer at Confluent, a member of the project management committee for Apache Kafka, and a core committer, of course, on the same. He mostly works on Kafka streams. It's been a while since we talked about Kafka streams on the program, so I had Matthias bring us up to speed, and in particular focus on interactive queries and some of the changes being introduced in interactive queries in recent releases. And before we jump into that interview, remember the Real-Time Analytics Summit is coming up. If you go to rtasummit.com, you can register, and if you use the discount code RTAPOD30, that's RTAPOD30, you get 30% off your registration. I hope to see you at the conference. And for now, let's jump into the conversation with Matthias. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm very happy to have on the show my friend, former coworker, Kafka PMC member, software engineer, et cetera, Matthias Sax. Matthias, welcome to the show.
Thank you very much. Very happy to be here. Long-time listener, first-time caller. So excited that we can do this.
Yes, me too. It's been it's taken too long to get you on the show. So
yeah.
Thanks for making time for me. I was saying before we started recording, I like your pillows. You got Confluent on one side and the Reno pillow on the other side. It's a good framing, and the Kafka t-shirt, Firewall Kafka in the middle. All of this, sort of the mise en scène here on your side is excellent. So
yeah, I need to get some personal branding into this as well.
You really do. You really do. Of course, on my side, I'm known for that, but I've been moving house serially for the last couple of years. So right now we get this nice black background and the studios at StarTree here in downtown Mountain View, and it works well enough. So
cool.
All right, we're going to talk about Kafka streams today, and in particular, IQ2, Interactive Queries 2, which is a feature that has been in development for a few releases. I'm not sure when it started, but you can tell us that. And I'd love for you to tell everybody what Interactive Queries is, in case you've missed that. I think we did an episode on it last summer. But first, in case for new listeners, just tell us what Kafka Streams is. It's the thing that I think you focus on the most. Summarize Kafka Streams for us, and then we can get into Interactive Queries.
Okay, very happy to do so. Question is, how long can the summary be? Let's start.
20, 30 minutes,
Yeah, exactly. It's just the basics. So basically, Kafka Streams is a Java library, and it's part of the Apache Kafka project. And it allows you to do stream processing with data that is stored in Kafka. So you basically consume a data stream from Kafka topic, you do your processing, and then you write the results back into Kafka. And the nice thing about Kafka Streams is really it's a library, so it's very easy to use. And at the same time, it's a fully fledged stream processor. So it's basically as powerful as like an Apache Flink, you could say. There's like different trade-offs, but it supports stateful stream processing. It supports, exactly once processing and stuff like that. And so it's also distributed, obviously, for the same reason. It's on the Kafka Consumer Group protocol. And so the main difference to a system like Flink is really in Flink, you have your processing cluster where you deploy your job. And in Kafka Streams, there's no processing cluster because in the end, it's a library. So you basically just deploy a Java application, and the magic happens inside of your Java applications that you deploy.
Yeah, the theory being that you already have a way of creating a Kafka consumer, and those are already horizontally scalable. The basic machinery for scalability is there. So this just enhances that JVM application with all the things it needs for stream processing. And I do mean all. It's a very complex story back there. So now your Kafka, your consumer in Java is a fully fledged stream processor.
Exactly. And you don't see all the nitty-gritty details of the consumer. It's all abstracted away. So we have a high-level fluent IPA that is basically, it's like functional style thing. We basically say, read this topic as a stream, apply a map, apply a filter, do a group by an aggregation. And then, of course, you can also enrich it with like custom processes if you need to.
Yes. I want to let the record show. Matthias said IPA. This is later in the afternoon that we're recording this. You meant API. I think it's Mountain Time where you are, right? Are you Pacific?
No, I'm Pacific.
You're Pacific still. Yeah. It's close. we're recording a little later in the day, might be thinking about a beer, and I don't think there's any harm in that. API, IPA, very, very similar.
Happens to me on a regular basis.
That's amazing. Got it. So it might be interesting. Let's kind of see if we have time to talk about the trade-offs and just the different spaces between Kafka Streams and Flink that they occupy in the world. Because I've always seen them as, I don't like to say rivals. That's odd, but like you pick one or you pick the other. And Kafka Streams is I've just always thought of really interesting, and I mean interesting in a good way, set of decisions about how to get stream processing done. Like, hey, just be a library. And I don't know, you're a committer and PMC member, and this is what you spend your full time on. So to the extent that you know of the way folks are using it in the world, how often do people write a Kafka Streams application whose only job in the world is ingesting data, doing things, and then producing data back to a new Kafka topic? Like the job of the application is to put these value-added events in the destination topic, having done the Kafka Streams thing. How often is it that case? And how often is it, I am a microservice with some life of my own and some other APIs and other ways of talking to the world, plus I need to do stream processing? Give a sense of that.
Hard to pin down. I mean, in the end, I would say 95% do publish back to Kafka for sure. But how many of those basically interact with external APIs, that's hard to estimate. I mean, I'm pretty sure it's a decent amount. One problem is there is not really built-in native support in Kafka Streams. People do it anyway all the time because it's just like how you build microservices.
Yeah.
But putting a percentage on it is difficult, actually.
Yeah.
But yeah, I mean, in the end, the point is really, because you mentioned the Flink thing, right? It's really the deployment model and how you basically want to roll out. So because we know that a lot of people basically say, well, we're companies, we have like orchestration framework to deploy our microservices in general.
You kind of need that.
So it happens to be that, a certain percentage of these microservices are Kafka Streams applications, but all the others are not. So basically now you just deploy it in the same way, nothing changes. If you would switch to Flink, you couldn't do that, right? You would need a different deployment process now for your Flink jobs because it doesn't fit the pattern anymore. And then a lot of people just say, no, Kafka Streams can do the same thing. Of course, there's a lot of details and a lot of differences as well. They're very subtle, but there's an overlap. And then it's like, whatever fits better for you. And I think the other point is also it depends a little bit on the organization. So if you're like in a bigger company and you have a central team that is operating the Flink cluster for you, yeah, sure. I mean, it's easy for you to write your job and to submit it. But if you don't have that and you're a smaller team and you cannot run your Flink cluster yourself, then running Kafka Streams can be much simpler because you don't need to worry about operating a Flink cluster by yourself.
Right. Now, one really cool thing about Kafka Streams that I think sets it apart as one of the stream processing solutions is its ability to create tables out of streams and make those tables queryable. And that's the interactive queries feature. So tell us, again, we'll link in the show notes to episodes where we've deep dived on this, but for those listening right now, just give us a top level summary. What is interactive queries?
Yeah. So as I mentioned, Kafka Streams allows you to do stateful processing. And then the high-level API, as you just mentioned, we basically model this as tables. We call it K-tables. And those K-tables are basically implemented as a stateful operator using a RocksDB that is running inside your application to maintain the state. And I mean, going back to the Flink thing, right? Flink also has operator state, but they don't model this as a table, so it's not a first-class citizen there, like in Kafka Streams. And that, I think, is a big difference in the API. And now, basically, while you do the processing and the state changes, once in a while, you just say from outside, hey, basically, what is the value for this particular key? And you want to look it up. And now this interactive queries comes into play that allows you to actually tap into the state directly and read out those values to see what's going on in the application.
There you go. And if any of that was not clear, I want to fill in a couple of blanks, or not blanks, but a couple of things there that were hard for me when I was first trying to understand this. And that's the state from a stream, et cetera. So imagine you've got a Kafka topic. There are events that are inbound, that you're ingesting into your Kafka streams stream processor. Each one of those events, it's a message in Kafka, so it's a key value pair. And you do something with it. And let's just kind of leave that blank right now. Maybe you're not really doing any computation. You just want to look up the value for a given key in that topic. The key is maybe like a user ID or something, and you want to see, okay, what's the current thing that user is doing, current state of that user, whatever that is. Well, you can just have Kafka Streams turn that topic or that stream into a table, and so the key becomes the way that you access the key value store, little RocksDB database or whatever you want to call it. In Kafka Streams, you're going to call it a K table. So you turn that stream into a table. That can also be the result of computation, right? Like maybe you're grouping by some field in a message and summing something, whatever, all those things create tables. And this is a theme that comes up in stream processing, and particularly with an analytics focus. You're going to turn those events into tables.
Yeah, absolutely. I mean, tables are a great abstraction, right? And I mean, usually tables are very often seen, especially if you look into the analytics space, as something that is kind of immutable, right? You basically have your data warehouse, you load your data once, and then the data doesn't change. Right. But of course, if you combine this with stream processing, then you basically go a little bit more into the notion of like continuously updating tables or continuous materialized views. And that is really what a K table is in Kafka Streams.
Yes. And that's an interesting point. So in the Pinot world, we talk about upserts.
Yes.
And when you think about, like you said, traditionally in analytics, you're taking the stuff from before, immutable things that have happened, and you're just summarizing them, finding the story and then doing whatever, analyzing them, if you will. But in event-driven and real-time systems, some of those things that are participating in the analytic computations, the analytic queries, might not be pure events. They might be entities that change over time, like orders or people or things like that change state. And so a stream processing topology in Kafka Streams that creates a K table might be ingesting one of those mutable entities. And so you have a constantly updating version of it in the K table, yes. Which is the Kafka Streams way of doing that. You don't even really say upsert. It's just like, well, of course, that's, this is materialized state.
It is the exact same thing. It is an upsert, right? I mean, with Kafka tombstones, right, we also have deletes. So it's really a full feature flagged thing.
So, walk us through interactive queries and in particular interactive queries 2. Like, why is there a 2? You said this is basically the way that you query one of these K tables. You give it a key and it gives you a value. Like, what's that API look like, and what does 2 give us that one didn't have?
Yeah. So as you said, I mean, basically we can do more than some primary key lookups. You can also do some range scans and stuff like that. It's all key based. That is important. And that's also like a different angle how to look at it. So, I mean, some people say, we materialize the data in RocksDB, what is not incorrect, but the data is already materialized in the topic itself, actually. So for me, to some extent, it's kind of an indexing technique. You basically index the data in RocksDB and apply the primary key. Similar what Pinot does, of course, with a much more advanced index, with StarTree index compared to
choices of indexes. Sure. I mean, it's trying to be a database, not a stream processing framework. So that stands to reason.
And because of those difference, we are not a database, right? We also don't have secondary indexes and stuff like that. But yeah, we basically ingest the data, and then you wanna find those things. And so in the original API, we have the corresponding interfaces for the different types of stores. Let's say you have a key value store. We also have like windowed stores and stuff like that. And when you say, I want to query the store, we basically just give you this in the read-only interface, and you have, all the available methods, and you just, call them. So you can do a get, or you can do a range, or whatever you have. The problem is that there is like a very tight coupling between the internal implementation of the store and the actual interface that we provide you to access the store. And the idea of IQv2 is to actually decouple those. And so instead of saying, I want to get a handle on the store, I get the interface back, I basically say, no, I actually have a query object now that I create. It's like a Java class. And then I submit the query object into a store. And now the store can say, I implement this query and I give you a result back. Or I could say, well, I don't support this type of lookup, so I reject it. But now the things are kind of decoupled. And now you can also in the backend, change the store without impacting the public facing API of the query layer, while before that was covered.
Of course. Okay. I love that. Yeah, because you can still only do queries that the store will support. Like if it's a key value store and you need to do a range query, I'm just assuming there needs to be something different about the store to do the range query. It's fair to say, hey, I don't support that. I'm not set up for that. So you still kind of need to know something
Sure.
to know what kind of queries, to have a plan for what kind of queries you will be able to throw at the store. But I like taking implementation details about the store out of the API, right? Because life is already hard. Like I have to do my taxes and take the trash out. And now I have to know things about this API based on its implementation. Yes. And that, to the first two are enough. I don't want to have to do that.
Exactly.
And again, it doesn't this is always the case in API design, right? You're trying to abstract things, and it's always a little bit of a lie if you overstate it. No, you don't need to know anything. Well, of course you do, but it's not in your face, right?
Yes.
Get a query, you send it to the store. That's the thing that I want to do.
Yeah. And the other point was also once in a while we actually wanted to add like methods for like internal processing, makes the store more powerful, but it was never meant to be used for users to use it as a external interactive query access to the store, right? But now, of course, you leak all those things into the API in the first version, and the second version, it's just like hidden, right? Now you can modify the store, but the query layer doesn't change.
Okay, so you can do things for your own internal purposes that you're not going to expose to IQ.
Exactly.
Again, we take a query object and we probably give you results. And that's what you need. Servers, whatever you want to call them, all running the same consumer image. It's a Kafka Streams application. It is precisely the same program deployed to all three machines, and they connect to the Kafka cluster. The consumer group protocol does its thing, or Kafka Streams gets involved in that maybe a little bit. Partitions of the Kafka topic get assigned to those three nodes through some mechanism. And if you're only listening and not watching the video, I'm literally waving my hands in the air right now. So partitions get assigned to those three instances. Each of those three servers has a RocksDB instance, at least one, associated with the state that they're materializing. And let's say you're through some process, you're creating this stateful K table, and little slices of certain partitions of that K table live on each node. Good so far?
Right.
All right. Now, I want to, I'm some other application, I'm some other microservice, and I want to look up a key. What do I have to know? Where do I send that query? How does that all work at that point? And what's the protocol look like? Like, make that concrete for people.
Yeah, absolutely. And I have to say, so Kafka Streams basically provides the basic building blocks for that. So basically, we're talking about a query routing problem now. I know one node only hosts the data, and I don't want to query all three of them. So, you could do that. You could be naive. You can send the query to all three of them. Then two will say, not found. One will give you the result, and you're done. With 3 nodes, that might be okay. If you have like 20 nodes, you don't want to do that anymore.
That's going to feel bad.
Yeah, exactly. And so what Kafka Streams is, so if you go to an individual node, you can only query the local data, obviously. But you can also ask every node, where are the other partitions? So if I get a key, I can ask, do you host this partition? And then the instance can say yes or no. And if it says no, it can actually also tell you, oh, by the way, it's this other instance. And I give you the exact information where you find this other instance. And then you can route the query, but that's something you need to implement yourself, forward it to this other instance. And then the other instance says, yeah, I host the data and I can answer the query for you.
Okay. And what do you get back in that request is, it's a request to tell me what node of
yes,
the
in
Kafka
the
Stream
end, it's something you configure yourself. So every Kafka Streams application can be configured what we called, I think it's called application.server. It's a string, and you can configure anything you want. And usually you would, say, if you deploy in a pod, you say, pod name, whatever, or, IP address, whatever, port, whatever. And then basically we give you back this string that is configured in this other instance, right? Because we know. So let's say you have 3 instances. I go to instance 1. I ask for key foo. It knows key foo is on instance 2. So it has this information, what the application server configuration of the second instance is, and gives you back and says, hey, this is hosted in this instance. And then you have to interpret the data because you configured that. What tells you how do you find this other instance now?
Got it. So it could be an IP address or a key that you use to look up in some whatever service discovery thing you've got. However, It is, you do that. And is that, betraying my ignorance here, is that a separate API call to do that query routing, or is that a response you get when you ask for a key and it's not on that node?
No, that's something you have to implement yourself. So basically, the node itself, you can basically either issue the query directly, and it doesn't even check if it has the key or not. It just does a lookup and says, result found, yes or no.
That makes sense.
Or you explicitly say, give me the instance that is hosting this key. So this is a metadata call into Kafka Streams.
There you go.
And then Kafka Streams gives you a result back, and then you can say, well, if the metadata says this is the application server, and I look up my own configuration and it matches, well, then it's local. And if it does not match, then it's remote and I have to go somewhere else.
There you go. Where does that, out of curiosity, where does that metadata live? That key to node mapping? That sounds hard to do.
Just in memory, basically. Because it's part of the configuration of the Kafka Streams. So you pass it in as a configuration parameter, and then we basically piggyback this information into the consumer group protocol to broadcast it to every node. So everybody knows who is in the group and who has the configuration. And that is how we can do the mapping.
Right.
And in combination with the partition assignment, right, we can stitch it together.
Okay. But the actual mapping of key to node, that mapping is could be larger if you have a lot of keys, right?
Yes. I mean, the point is we don't really need to store it explicitly. We basically say, well, if you ask us who is hosting a key, then we just compute dynamically the corresponding partition it needs to live on. And we can map the partition based on the consumer reap protocol onto the node, right? So we don't have to store the key space. We compute it dynamically.
Computed. It's not, of course.
Yes.
Okay.
It's computed, yeah.
Yes, because we probably do that by hashing or something like that.
Yeah. And if you don't pass anything in, we just assume it's a default partitioner that is used in Kafka, what is like the murmur2 hash. But you can also pass in a custom partitioner into Kafka and also into the IQ API to say, by the way, I hash differently, right? So please compute the right node based on whatever I provide to you.
Right. And at that point, that sounds like a headache. And I'm sure you're very pleased with yourself at that point for the custom partitioning that you convinced yourself you absolutely had to do. You just couldn't use Murmur2 and the message key. Now could you? Yeah. And now you've got this other thing. But
and to be fair, I mean, once in a while, it's not even into the control of the user because the default partition in Kafka is not really standardized. And of course, it's a standard in the Java world, but we know that other libraries in other languages use a different default. And we very often had some surprises. So for example, if you use also Liberty Kafka clients, they don't use Murmur2 by default. It supports it, so you can reconfigure it, but it's not the default. So a lot of people, they write the data with Python, they write the Kafka Streams application, put the data into RocksDB, say, issue a query, and they don't find any data, and they're confused. Because, of course, our IQ hashing mapping is different, and then we have to tell them, well, either change upstream or pass in a Kafka, the custom partitioner that maps whatever the Python client is doing, and then it works again.
And they will only randomly get the right answer. So with 3 nodes, a third of the time you find keys and 2/3 of the time you don't, and you don't know. Okay.
Yeah, exactly.
All right. Well, that makes sense. So you have to do a little bit of thinking ahead if you've got different languages, if it's not an all Java kind of situation. And again, for the uninitiated, Matthias just mentioned LibRd Kafka. That's a C library. That's the foundation of most of the non-JVM Kafka libraries in the world. Is there? There was a pure Go one a few years ago. I don't know where that's gone, but usually.
Yeah, there's a couple. The point is, I mean, there is, I think, clients in 20, 30 languages. The question then is how good they are from a quality point of view. I would not put everything into production here. Right. So the ones that are maintained by Confluent are most of them are based on Liberty Kafka. We recently actually added a new JavaScript client. It's still in early access, but that's not based on Liberty Kafka. That's native implementation.
Okay, so finally, JavaScript. This is a slight rabbit trail that I've brought our guest on. Thank you, Matthias, for coming on this rabbit trail with me for a moment. But that's great to know. There's a at least pre-production native JavaScript library. The time has come. Some would argue the time was a while ago, but that's great to hear. And,
I mean, there was one before. I think the problem was that this was not maintained anymore. And so people basically, a lot of people want that. So we just pick it up and, push it out.
And do it. Wonderful. Wonderful. Yeah. But for the most part, it's Liberty Kafka or the native Java library wrapped. If it's not Java, it's, whatever adjacent JVM language. All right. Okay. Hey, you've helped me level up on interactive queries, and I hope it's clear. We're spending a lot of time in the details. I hope it's clear how this plugs into the broader real-time analytics ecosystem. I mean, Kafka is a tool, and Kafka Streams is a tool for writing your own real-time analytics topologies, is the Kafka Streams term. Stream processing flow in Java or an adjacent JVM language. So very much a part of the stack. And we'll link to the episodes from the summer when we kind of talked about when would you use Kafka Streams versus this, that, the other. And I guess in conclusion, last question, kind of a quick rundown on your thoughts on the trade-offs. When would you use Kafka Streams? When would you use Flink? You already told us if you don't want a lot of deployment footprint, you just want to deploy like all your other Java applications. Any other considerations that would be in one's mind for thinking about that decision?
Well, I mean, we talked about interactive queries, so that is also a unique feature. So if you want to tap into state, I mean, Flink has some things that they called queryable state at some point, but it was always in beta status, and I'm never sure if they actually still maintain that. So that's not really a thing there. And then I think it's a little bit of a question of ergonomics of the API. So I think our stream table duality in the DSL is very unique as well, because it makes state a first class citizen. In Flink, it's basically everything is a stream, and then you basically have, of course, stateful operators for joins and stuff like that. But the state is basically an implementation detail. It's not a first class citizen. So it's a little bit harder to work with. Of course, Flink offers all kind of different APIs as well. There's a table API where basically they model everything as a table. And you can also bridge between both, but there's, some gaps, I would say. It's not as ergonomic as like the Kafka Streams DSL for sure, because it was never built as one API. It was built as two, and then later on it was integrated. So there's some differences here. And then, of course, I mean, Flink is much broader in general. I mean, you can do batch processing with Flink. You can do SQL with Flink, things Kafka Streams doesn't have. So if if this is your cup of tea, then, you have to go there, because we are all Java only, or JVM only. Let's put it that way. It could also be, as you mentioned, Scala or whatever languages you want to use with Kafka Streams together, as long as it's JVM based. And that really says the main differences. And then, of course, it's integration with Kafka itself. I mean, Kafka Streams is part of the Apache Kafka project, so it's deeply integrated with everything. And every new release of Kafka Streams uses everything that is new in Kafka. Flink very often, they use what they need to, but, there's, of course, it's two different projects. It's independent. So once in a while, the Kafka integration is not as good. Usually it's reasonably good and it's fine, but there's, of course, differences.
My guest today has been Matthias Sax. Matthias, thanks for being a part of the Real-Time Analytics Podcast.
Thanks for having me.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.